Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL November 2021 paper 2. Today we will be solving the last question of this paper, that is question number 11, and you will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel. So, without any further delay, let us start answering question number 11. The maximum mark is 21. It says 3 points A with coordinates 3, 0, 0, B with coordinates 0, negative 2, 0, and C with coordinates 1, 1, negative 7 lie on the plane pi 1. Subpart A has two further subparts. The I says find the vector AB and the vector AC. Okay, so I start my answer from this point. AB. So this should be 0, minus 3, minus 2, minus 0, and 0, minus 0, which is equal to minus 3, minus 2, and 0. Okay, and vector AC. So AC is equal to 1 minus 3, 1 minus 0, and minus 7, minus 0. This is minus 2, 1, and minus 7. So these are the two vectors, vector AB and vector AC. You may write these in unit vector form as well. AB will be minus 3i minus 2j, and AC will be minus 2i plus j minus 7k. Okay. Coming to the II part. So this is saying, hence find the equation of pi 1, the plane pi 1, expressing your answer in the form of ax plus by plus cz equal to d, where a, b, c and d are integers, and this contains the whole subpart A contains 7 marks. Okay, so for this we will be using the equation of the plane, this one, n dot r equal to n dot a, where n is the vector which is normal to the plane pi 1, and r is the position vector of any arbitrary point with coordinates x, y, z, which is lying on the plane y1, and a is the position vector of particular point which is lying, whose coordinates are known and which lies on the plane pi 1. So we may take the point as A or the point as B or the point as C, because all these points lie on the plane pi 1. Okay. So, but first of all, we have to get the n vector. The n vector is the vector which is perpendicular to the plane pi 1. And for that, we will be using the cross product, the vector product of what? Of AB and AC, because AB and AC are the two vectors lying on the plane pi 1, and they are two non-parallel vectors because they are having a common point between them, that is the A point. So these two are non-parallel vectors which lie on the plane pi 1. So Their cross product will be giving us a vector which will be perpendicular to both the AB vector and the AC vector, and hence it will be perpendicular to the plane phi 1. Okay. So this will be actually equal to n. And this is ij a. And first of all, I'm taking AB because I have written AB first. So this is -3 -2 0. And this is -2. AC is -2, 1 and -7. This is equal to, for I, I'll be taking this part. I'll be taking this part. So this is -2 times -7 is 14, minus 1 times 0 is 0. So 14 minus 0 I, and then for J, I will be writing a minus sign in front. And for the J, let me take one more color, different color. For the J, I will be taking this part and this part. Okay. So it is -3 times -7 is 21. Minus -2 times 0 is 0. And plus, let me take a third color. Okay. So for K, we will be using these two columns. -3 times 1 is -3. And this is -2 times -2 is 4. So -4. K. Okay. So this is equal to 14I minus 21J minus 7K. This is the n vector which is normal to the plane phi 1. Okay. So now we will be writing, and the r vector is what? R vector is, I can write it over here. So r vector is the position vector of any arbitrary point with coordinates x, y, z. So the position vector means from the origin to this point. So the r vector will be xi plus yj plus zk. Okay. And now we will be taking the scalar product, the dot product between n and r. So let us write the two vectors, or I have written them together. Over here is the n vector and over here is the r vector. So dot product, so it will be 14 times x. So this is 14 times x, that is 14x. This is -21 and this is y, so -21y. And this is -7, this is z, so it is -7z. This should be equal to, I need one more vector. This is the position vector of any point. I am taking the point A. So the position vector of the point A will be OA, or this is this. which will be equal to 3i, because 3 minus 0 is 3, plus 0j plus 0k. Okay. So now again 14 times 3 is 42, plus negative 1 times 0 is 0, and negative 7 times 0 is also 0. So it is simple 42. Okay. And you may divide this entire equation, even if you keep it this way, it is fine. Or else you may divide this entire equation by 7, so that you can get this equation of the plane as 2x minus 3y minus z equal to 6. Okay. This is the equation of pi 1. So we have completed answering subpart A. Let me bring the next subpart. Plane pi 2 has equation 3x minus y plus 2z equal to 2. And subpart B says the line L is the intersection of pi 1 and pi 2. Pi 1 is having the equation of 2x minus 3y minus z equal to 6, and pi 2 is having this equation. Pi 1, the equation of pi 1 was found in subpart A. To verify that the vector equation of L can be written as R, this is the position vector of any arbitrary point for every point lying on this line L, which is equal to 0, negative 2 and 0. This is a particular point, coordinates of a particular point lying on this line L, and plus lambda times 1, 1 and negative 1. This is the direction vector of the line L. So this is a vector equation of line L. Fine. We have to verify. Okay. So what is the line L? I am just drawing an arbitrary diagram. It is not a perfect diagram. I don't know which one is pi 1 and which one is pi 2. I'm just drawing an arbitrary diagram. So maybe this way. Don't know whether I am being able to draw the line, the two planes. Maybe this is the line L. This is the intersection line. So this is the line L. Just arbitrary diagram. You don't have to draw the diagram. Of course, this is just for explaining. So, and we have to verify the vector equation of line L. Because the line L is a line of this plane pi 2 and also is a line of this pi 1 plane. So that line L is lying both on pi 1 plane and on pi 2. Therefore, we can say that the line L, the equation of the line L, or the points which are on the line L, they will be also points on the two planes. Okay? Because line L is a line which is present in both the planes. So every point on the line L also the points of the two planes. Okay. So let us just take the arbitrary point, one arbitrary point on the line L. Okay. So let XYZ be an arbitrary point on L. Okay. Therefore, from this equation, we can say the x coordinate will be equal to 0 plus lambda, which is equal to lambda. Y will be equal to negative 2 plus lambda, and z will be equal to 0 minus lambda, which is equal to minus lambda. Okay, fine. So this arbitrary point will be lying on this plane pi 2 and on this plane pi 1. Okay, so let us check. Let us substitute these values of x and y and z in terms of lambda, and let us try the pi 1 first. Okay, plane pi 1. So this is 2 times x is lambda, left hand side. 2 times lambda minus 3, and y is minus 2 plus lambda minus z. So minus of minus lambda. What is this equal to? 2 lambda plus 6 minus 3 lambda plus lambda, which is equal to 6. So this is the right hand side of plane pi 1. So if we take the coordinates as lambda to negative 2 plus lambda and negative lambda, the coordinates of a point, that point is satisfying this plane equation. Hence, that point is on this plane. Let us check the plane pi 2. Okay. Left hand side equal to 3 times lambda minus of minus 2 plus lambda plus 2z. So plus 2 times negative lambda equal to 3 lambda plus 2 minus lambda and minus 2 lambda equal to 2, equal to the right hand side of this equation. Okay, so this point is lying on the plane pi 1 and also on this plane pi 2. Okay, therefore the equation, the vector equation of L is R, because from this we had just taken an arbitrary point. Every point on this line L will be satisfying this vector equation. So I have just taken an arbitrary point which is on the line L, and I have seen that that arbitrary point is lying on both the planes. So every point on line L will be lying on both the planes. Hence, the line L is present in pi 1, plane pi 1, and also present in pi 2. Therefore, this is the line of intersection of two planes. Okay. The two planes can intersect in a line if they are not coincident. Okay, so they are intersecting in a line. They have said the line L is the intersection of two planes. Okay, so the vector equation of L is R equal to 0, -2 and 0 plus lambda 1, 1 and -1 verified. Okay. So we move on to subpart C. Subpart C. The plane pi 3, third plane, is given by 2x minus 2z equal to 3. The line L and the plane pi 3 intersect at the point P. Maybe these are just rough sketches. This is the plane pi 3 and maybe this is the line L. Okay. And this is the point P where the line L is crossing the plane pi 3. Fine. And subpart I says, show that at the point P, lambda value is equal to 3 over 4. From where are you getting the lambda value? This is the vector equation of the line L. Okay, so this is lambda. Fine. And in our last subpart, we had seen that any point or every point of this lying on this line L will be having coordinates of this form x equal to lambda. The lambda values will be different for different points. So y value will be -2 plus lambda and the z value, the z coordinate will be negative lambda. This is true for every point on this line L. And for the point P, this is subpart I, since the point P lies on pi 3, therefore two, in place of x I'll be writing lambda, minus 2, and in place of z I'll be writing negative lambda, should be equal to 3. Okay, because this point P's coordinates will be satisfying the plane equation, because this point P is on this point on this plane pi 3, sorry. So this is equal to 2 lambda plus 2 lambda, that is 4 lambda equal to 3, or lambda equal to 3 over 4. Shown. Okay. Now coming to the subpart II. Fine. Hence, find the coordinates of point P. Now, since we have found the value of lambda, it is 3 over 4 for P, as I have said earlier, that every point on this line L will be having coordinates of this form, lambda, -2 plus lambda and negative lambda. The lambda value will be different for different points. For this point P, the lambda value is 3 over 4. Therefore, the coordinates of point P R, lambda is 3 over 4, y is negative 2 plus 3 over 4, and negative 3 over 4, sorry. So this is fine, 3 over 4, that is also fine, negative 3 over 4. I have to just get this part. You can use your calculator because this is paper 2. This is very elementary calculation, so I am doing it over here. I can write this as 8 over 4 because I need a denominator of 4. Negative 2 can be written as negative 8 over 4 plus 3 over 4, which will be equal to negative 5 over 4. Therefore, P 3 over 4, negative 5 over 4, and negative 3 over 4. Okay. Fine. We have answered subpart C. Let us move on to subpart D. Subpart D. The point B 0, comma negative 2, comma 0 lies on L. It is containing two further subparts. The I says, find the reflection of the point B in the plane pi 3. So maybe this is the sketch. Let me draw the sketch once more. The rough sketch. This is pi 3. Maybe this is the line. Okay. It is actually a straight line. Don't consider this to be a curved line. It is a straight line. This is L. Maybe this is the point where the line is crossing the plane pi 3. So this point is P. These were are the coordinates of this point P. We had found the coordinates of point P in subpart C, and this is the equation of the plane pi 3. This is the vector equation of line L. Okay, and they are saying that point B is also on line L, maybe over here. These are just arbitrary points I am taking, arbitrary, plain arbitrary, just a schematic diagram, not drawn to scale, definitely. So, and they are asking for reflection of the point B in the plane pi 3. Because it is the reflection, I have to drop a perpendicular from this point B. This is the point B, maybe. I have to drop a perpendicular from this point B onto the plane pi 3, and it will be just moving down below the pi 3, and maybe this is the point of intersection. Okay, so this is the object distance. Actually, let me read the II part also. Hence, find the vector equation of the line formed when L is reflected in the plane pi 3. Okay, but this I, we can get the reflection, the coordinates of the point of reflection of this point B using different methods. I will be using partly the vector method and partly the coordinate geometry. Okay. So I'm just dropping a perpendicular from this point B onto the onto the plane pi 3, and I'm just extending it below the plane. And this is the object distance, this part from B to where this perpendicular is intersecting the plane pi 3. This is the object distance, and this part is below the pi 3. This part is the image distance. Okay. And we know, since it is the reflection, pi 3 is considered to be the mirror. So object distance equal to image distance. Therefore, I can consider this point to be the midpoint of this line segment BB dash. Okay, that is what we, at least even if I assume that you have not taken physics in your IBDP level, you had physics in your IGCSE level, so you know that for case of reflection, the object distance is equal to the image distance. So this is the mirror point where this line BB dash is crossing this plane pi 3. This pi 3 is considered as the mirror. So this point will be the middle point as this line segment BB dash. So I'm naming it as N. Fine. And since it BB dash, this one is perpendicular to this plane pi 3. From this equation of pi 3, it is 2x minus 2z equal to 3. So what is the equation of the normal to this plane pi 3? So I'm starting over here. So normal vector three perpendicular to pi 3 is 2 plus 0y, so it is 0, and negative 2z, so it is negative 2. Okay, so this is the normal vector. Now I am getting the vector equation of this line BB dash. Okay, so I can write this line, the name of this line as L1. Okay, let the line passing through BB dash be L1. Okay? Therefore, L1 is equal to, this point B is on this line L1, so the vector equation I am writing. So this is L1, rather this is actually the vector equation. So let's erase it and write it clearly. Okay. Zero, negative 2 and 0, because this is the position vector of this point B, which is definitely on this line L1. Okay. And plus, maybe I'm taking the parameters lambda, and it is what is the direction vector? Lambda times the direction vector. The direction vector is the vector which is normal to the plane pi 3. So I'm taking the direction vector as this. So this is the vector equation of the line L1. Okay. Now, as you know, the every point on this line L1 will be having coordinates as x equal to 0 plus 2 lambda, that is 2 lambda, y as, I had written the arbitrary points coordinates in the first subpart A or B, I don't remember exactly, but I'm not writing over here, I'm just explaining, so I'm not writing those details over here. X equal to 2 lambda, y equal to minus 2, and 3 equal to minus 2 lambda. Okay. And this point, if I take this point to be the coordinates of this point M, because these are the coordinates of every point on the line L1. The lambda value will be different for different points. So if we consider this point to be the coordinates of the point M, then point M is on this plane I3. So these coordinates should be satisfying this plane equation 2x minus 2z equal to 3. We want to get the value of lambda. Okay, because I want to get the coordinates of the point M. So I can do one thing. I'll be substituting the x value and the z value in the plane equation. Therefore, 2 times 2 lambda minus 2 times negative 2 lambda equal to 3. So this is 4 lambda plus 4 lambda, that is 8 lambda equal to 3, or lambda equal to 3 over 8. Okay. Therefore, the coordinates of M will be 2 times 3 over 8 is 3 over 4, and then minus 2, and then minus 2 lambda. So minus 2 times 3 over 8 is minus 3 over 4. Okay. And then, since I know that the object distance is equal to the image distance, therefore M is the midpoint of this line segment BB dash. Let me just take the coordinates of the point B dash, P, X, Y, and Z. Don't get confused with this XYZ with these XYZ. Okay. Of course, B dash is also on this line L1, so these also will be satisfying this relation. But anyway, I want to get the coordinates of the point B dash. Therefore, I can write the coordinates of the point B are, let me just write over here the coordinates of the point B. These are 0, let me just show you over here, 0 and minus 2 and 0. So, therefore, 0 plus x over 2 is equal to 3 over 4. Therefore, x equal to 2 times 3 over 4, which is 3 over 2. Again, y is what? Y, and this is minus 2. Y minus 2, I could have written minus 2 plus y also, over 2 is equal to negative 2. So y minus 2 will be equal to negative 4, and y will be equal to negative 4 plus 2, that is y is equal to negative 2. And c plus 0 over 2 is equal to negative 3 over 4. Therefore, c is equal to negative 3 over 2. I am just using the coordinate geometry knowledge. You can use your vector knowledge also, no problem. I just wanted to use the coordinate geometry knowledge. So we have got the coordinates of the point B dash. Therefore, B dash will be equal to 3 over 2, negative 2, and negative 3 over 2. Okay. So these are the coordinates of the point, the reflected point of B, that is B dash. And I don't have any space for this subpart II. I'll be moving on to the next page for the answering of this subpart II. Okay. II. Hence, find the vector equation of the line formed when L is reflected in the plane pi 3. And so let me draw the rough sketch once more. This was the plane pi 3. This was the line L. This was the point, maybe this is P. This was maybe B. This was the perpendicular. This was M. This was B dash. Okay, and this line was L1. Okay. Now they are saying when L is this line L is reflected in the plane pi 3. We have seen this point is on line L, and when it is getting reflected on this point pi 3, it is coming over here. This point P is also on the line L, and it is on the point pi 3 as well, on the plane pi 3 as well. So therefore, its reflection will also be the same point P. Okay. And if you consider this point somewhere over here, if you reflect this point on this plane, you have to again drop a perpendicular, and then it will be again this point may be M1, and this may be C, M1. So image distance equal to object distance equal to image distance. So maybe over here it will be C prime. Okay, C dash or C prime. So this will be the reflected point of this point C on the, which is C point is on the line L, and it is getting reflected on this plane pi 3. So this C dash is on the reflected line L, because every point on the line L will get reflected on the point P, on the plane P. So I have got 3 points on the reflected line. So I can just join them. So this is the reflected line. Maybe this is L prime, L dash. Okay. So we have to get the vector equation of this L dash. Therefore, it is better you sketch this so that it becomes very clear what are you implying to say. So we need one point whose coordinates we know, which will be on this L dash. Therefore, I am taking the coordinates of the point B dash. B dash is on line L dash. So I am taking the coordinates of the point B dash. They are 3 over 2 and minus 2 and negative 3 over 2. And then I have to get the direction vector, because it is the vector equation. I have got the point which is on the line L dash. So I know the position vector of this line, this point B dash. It will be 3 over 2, negative 2 and negative 3 over 2, column vector. And then I'll be having the plus some parameter, and then I needed the direction vector. For this direction vector, I have to use this. Let me get the direction vector PB dash. So PB dash 3 over 4, sorry, 3 over 2, B dash, so 3 over 2 minus 3 over 4, minus 2, minus of minus 5 over 4, and minus 3 over 2, minus of minus 3 over 4. Okay. So what is PB dash? 3 over 2 minus 3 over 4. 3 over 2 is 6 over 4. 6 over 4 minus 3 over 4 is 3 over 4. Okay. You can do the rough work over here. And this one is minus 2 plus 5 over 4. So minus 2 can be written as minus 8 over 4 plus 5 over 4, which is equal to negative 3 over 4. And this one is negative 6 over 4 plus 3 over 4, which is equal to negative 3 over 4. Okay. So this is also negative 3 over 4. Fine. So we have got the position vector of a point which is on the line L dash, and we have got the direction vector. So this is the direction vector. And therefore we are in a position to give the vector equation. Therefore, vector equation of the reflected line in our case that is L dash, is equal to R, position vector of any arbitrary point on the line L dash, equal to, and taking B dash, you can take the point P also. So it is 3 over 2 minus 2 and negative 3 over 2 plus maybe mu. You can write any parameter. And then the direction vector is this: 3 over 4 minus 3 over 4 and minus 3 over 4. Okay. So this is the vector equation of the reflected line of when the line L is reflected on the plane pi 3. Okay. So this brings us to the end of this question number 11 and also to the end of this full paper. So thank you for staying with me till the end. I'm Nilanjana Sanyal. I'm an online IB Math A, SL and IB Math A HL tutor. I tutor students from both within India and outside India. And currently, I am solving the IB Math A HL past paper questions. And in case you are liking my explanations, please do give these videos a like, and please to share these videos with your friends so that even they can watch these videos, these explanations. And in case you have some suggestions, in case you have some questions, please do feel free to write to me in the comment section, comment area. I'll be going through them definitely, and I'll be trying to answer your questions. Okay, your suggestions, I'll be keeping them in my mind. Okay, and I may do some modifications if I can. So, and please do subscribe to my YouTube channel. This will be motivating me to make more math videos for you. And we meet again very soon in our next session. We will be starting with 2022 papers from our next session. Oh, sorry, not 2022 paper, because we are having the paper 3 remaining. First of all, we have to solve the 2 questions of paper 3 of this November 2021, and then we can move to 2022. Okay. So till then, bye.